All right, you guys are going to have, your test is Thursday. So like I said, the test review is up. You're welcome to start working on it, asking questions, that sort of a thing. Formulas will not be provided to you, so you need to make sure that you know them. We did a problem like this the other day, but with the arithmetic. Remember, arithmetic is when you add or subtract to get to the next number. Geometric is when we multiply. So it's kind of the same process of how we found the common difference, and then we plug that in to find the term. We're going to do the same thing here. We just have to find the ratio. So again, this one's a little harder, but what is given to you? You're given that the fourth term, a sub 4, is what? 125? And a sub 10, the 10th term, is 125 over 64. Everybody see that? All right, so our formula to find any term in a geometric is a sub n equals a sub 1 times r to the n minus 1, correct? So there's a couple ways that you guys can do this. But the first thing we need to do here is we need to find the common ratio. We need to know how we get from one term to the next. So the first thing I'm going to do is say, okay, how many spaces, how many terms are between the fourth term and the 10th term? How many spaces? 6, right? 6 spaces. So in our arithmetic, we use that number multiplied by the common difference. We're going to do the exact same thing, but we're not going to use it times the common something. We're going to raise it to a power because that's what you have in a geometric, is you have an exponent. So we're going to take our terms and we're going to form a little equation. You always put the term that is the furthest away from the zero term, or the furthest away from the first term, on the left side of the equal sign. So I'm going to have a sub 10 equals a sub 4 times r, and then how many spaces away are these two? 6. So that's going to become your exponent. However many spaces away the terms are from each other is your exponent. So you're solving, the first thing we're going to do here is to solve for what our r is. So a sub 10, what's my 10th term? 125 over 64, right? What's my fourth term? 125, and then I have r to the 6th power. So we're solving for r. Everybody with me? Okay. So when I'm solving for r, I want to get r all by itself. I divide by 125, correct? You guys agree? Okay, this is 125 over 1. So this cancels out. I have a fraction divided by a fraction. What do we do? Keep, change, flip. So I'm going to say 125 over 64 times, this becomes 1 over 125, equals r to the 6th power. What happens with my 125s? They cancel, so I have 1 over 64 equals r to the 6th power. How do I get r all by itself? You take the 6th root, right? If it was a squared, you take the square root. If it was to the 4th, you take the 4th root. So I'm going to take the 6th root of this side and the 6th root of this side. So r equals, what number times itself 6 times gives me 1? 1. What number times itself 6 times gives me 64? 2. So what's your common ratio? 1/2. Okay, so we found that our common ratio was 1/2. Now, a couple different ways we can do this. All right, I know that my 10th term is what? What's my 10th term? 125 over 64, right? And what is the question asking me for? What do they want me to find? The 14th term. So 10, this is 11, 12, 13, 14. In order to get from one term to the next, what do we do every time? Multiply by 1/2. So you could multiply by 1/2 here and get the 11th term, then multiply by 1/2 and get the 12th, and multiply by 1/2, right? Or you can work it out algebraically. So I'm going to show you how to do that algebraically. Okay, so let's think about this for a second. What is the term that we're looking for? We don't have the first term. So you could go back and find the first term. You could, instead of multiplying by 1/2, you could do what? You could just multiply by 2, go back and back and back to get to the first term, right? You could do that. But algebraically, what term are we looking for? We're looking for the 14th term, right? Yes? Yeah. Okay. Now, we can use either term that they gave us. We can use the 4th term, because we know that, or we can use the 10th term. I'm just going to use the 10th one, because it's closer. And we're going to do the same kind of process that we just did up here to find r, but we already know r. What is our r? 1 over 2. So what's going to become my exponent? How many spaces are between 14 and 10? 4, right? 14 minus 10 is 4, so that's going to become my exponent. Whenever you're doing geometric, whenever you're trying to find one from the next and it's not sequential, you can just say, okay, how many spaces away is this? There's a couple ways you could do this. You could have found the first term. A good way to check it is to do this right up here, and you can see if you were right. But we don't know the 14th term. We are unsure of the 14th term. Now, if I used a sub 4 instead of a sub 10, right here, if I used a sub 4 instead of a sub 10, what would my exponent become? 10, right? Because if I use the 4th term rather than, doesn't matter. You guys have calculators, you're fine. So your 10th term was 125 over 64, right? Correct? That's what was given to us. So then I know my r is 1/2, and we're raising it to the 4th power. Now, on your test, I've already written all the questions and stuff like that. Every single question that could possibly have a fraction says no decimals. You have to keep things as a fraction. You guys have your calculators, but you have to be able to use it. So when I look at this and I simplify, I have 125 over 64. What is 1/2 to the 4th power? 1 times 1 times 1 times 1 is 1. Yep. 2 to the 4th power is 16. And then we just multiply this. How do we multiply fractions? Multiply the numerator. 125 times 1 is 125. Multiply your denominator. 64 times 16 is 1024. And that is your 14th term. Now, again, you can check that by going right here and saying, okay, my 10th term is this. Then multiply it by 1/2 to get the 11th. Then multiply it by 1/2 to get the 12th. Then multiply it by 1/2 to get the 13th. Then multiply it by 1/2 and you'll get your 14th term. But in this case, however many spaces away your terms are, that's going to become your exponent, and that's what you're looking for. Okay? All right, let's look at finite and infinite geometric sums. There's 2 different formulas. They look much more complicated than they are. All right, here is the formula for finite. What does finite mean? It ends, right? There is an ending. If you have a finite sequence or series, it ends. So there's different pieces to this formula. Your a sub 1 is your first term, correct? Your r, what is r? Your ratio, what you're multiplying by. And what is n? It's the number of terms. Now, some of you guys have issues knowing how many terms there are. So I'm going to show you a little thing that you can work on here. But if we're finding the sum, sometimes, guys, this will be a 1. Sometimes it's a 7. Sometimes there's an I instead of an N. The letter itself does not matter. The exponent does not matter. It could be I minus 1 or something like that. You're going to use your algebra skills to find everything you need. Okay? In order to find the sum, we need 3 pieces. We have to have the first term, we have to have our r, which is our ratio, and we have to have our n, which is our number of terms. Easiest way to find your number of terms, how many you have, is take the top minus the bottom and add 1. Top minus bottom plus 1. Now, when the bottom number is 1, it's always going to be whatever the top number is. So 12 minus 1 plus 1. What's 12 minus 1? 11 plus 1 is 12. So I have 12 terms here. When this number is not 1, that's when the top minus the bottom plus 1 thing comes into play. But just get in the habit of doing it every time. Say this was a 4, and you were like, how many terms do I have? It'd be 12 minus 4, and then you add 1. That's like that span of digits that we try and find, but that'll work every time. Your common ratio, your R, is whatever the thing is with the exponent. It's going to be 95% of the time it's in parentheses, but if it's not, it's the little thing that has the exponent. So your R here, your ratio is 0.3. And then how can we find our first term? Say it again. Okay, sometimes it's just the number before the parentheses. Sometimes it's not. What do we have to do to find the first term? Plug in what?
1.
Plug in 1. So when I plug in 1, I have 4 times 0.3 to the first power, right? So my first term is 4 times 0.3. You can do that in your calculator if you want to. What's 4 times 0.3? What is it? 1.2. Okay, so you can use this or you can use that. It doesn't matter. But just whatever the bottom number is. If it starts with 0, then your first term would have been 4. If it starts with 7, then you plug in 7. But what you're doing, in a sense here, guys, is you're taking 1, and then 2, and then 3, and then 4, and then 5, all the way up to 12, right? You're plugging every one of those numbers in, and then adding your answers together. Which you could, in a sense, do. But say you were trying to find the sum of like the first 400 numbers. That would take you too long. So you'd have to use this formula. So in order to find the number of terms, you take the top minus the bottom and add 1. That'll work every time. Your common ratio is the thing with the exponent. And then your first term, just plug in whatever this bottom number is to find the first term. So as we go through and we use this formula, I'm finding the sum of the first 12 of this geometric. So I look and I say, okay, it's a sub 1, my first term. So I have 1.2. You can use 4 times 0.3 if you want to. And that's going to be multiplied. And then you have to plug all this stuff in. So it's 1 minus r. What's our r? 0.3. Raised to the what power? 12. Good. Over 1 minus 0.3. Now this becomes a calculator thing. You have to know how to use your calculators, guys. What should be done first? The exponent. All right? If you want to simplify piece by piece, that's totally fine. If you want to try and put it in all together, again, that's totally fine too. But you just got to be careful. If I say 0.3 and I raise that to the 12th power, you get some really, really, really tiny number, don't you? Did you guys do it in your calculator? Like 0.00000. I don't suggest doing every little piece one by one unless you put everything that your calculator displays. You can't just say that's 0.000. It's not. It has a tiny little value. So you want to simplify the numerator. You could say 1 minus, and then you have 0.3, put in parentheses, 0.3 raised to the 12th power. What do you get? 0.9999999, right? Something like that, okay. So if you're going to do that, this needs to be 0.99999. Write out a whole bunch of them. You can do that if you want to. You can try to do everything in your calculator at one time. Again, this is the time to do it, so we know how to use our calculators. In the denominator, what's 1 minus 0.3? 0.7. So you get this, you can say 1.2 times, and then you could say 0.99999, just put a whole bunch of 9s, divided by 0.7. What do you guys get? What's the sum about? So in this case, you get like 1.7, 1.714. Now on your test, I will specify if decimals are okay. The reason why a decimal answer is okay in this case, why do you think? Say it again. Okay, it is too complex to make a fraction. What did we start off with? We started off with the decimal, right? If you start off with the decimal, then it's okay to get a decimal answer. But if you start off as a fraction and you don't know how to use your calculator to convert, then you're going to have a problem there. But here's a question. This is new. I put this in here. I don't think it was in your actual notes. Is it there? Oh, okay. I put it in. All right. How is this one a little different? How does this one look different? Okay, there's an I. Good. How else is it different? Does it start with 1 on the bottom? No. This is the exact same thing. Now, some of you are going to say, how do I know? It says find the sum. How do I know if it's infinite or finite? What does infinite mean? Goes on forever. What's the symbol that says this goes on forever? Infinity, right? In an infinite sequence or series, you'll have the infinity sign on it. So you know that this is finite. You know that this has a beginning and this has an ending. You can see it begins with 3, it ends with 16. Y'all see that? So my a sub 1, my first term, I have to find my ratio, and I have to find the number of terms I'm talking about. And then we'll plug it into that formula. So first of all, the easiest thing to see is what is our ratio? Negative 1/2. Good. Negative 1/2. Okay. Now, how do I find the number of terms? Okay. 16 minus 3 is what? 13 plus 1. How many terms are there? 14 terms. Good. And then how do I find that first term? What do I plug in? What am I starting with? What do they tell me to start with? 3. No, that I don't. They wanted the first term of this sequence.
So a sub 1 of the sequence, not of.
So I'm going to say 5 times 1 over 2, 3 minus 1. What does that give me? 5 times, it's negative, right? Excuse me. Negative to the second power. What do we get? I got 1.25, but is that what I want? What do I want? I want a fraction. What is 1? 5 over 4 is fine. You can use 5 over 4. What's another way I could write it? 1 1/4, whichever. But if you start with a fraction, guys, we started with a fraction, then I want a fractional answer. So now when we go to plug in our formula, I want the sum of the first 14. Okay, so my first term is 5/4. Now again, if you want to use decimals, that's fine. Just make sure your answer is in a fraction. So I have 5/4, and then in my parentheses, what is my formula? It's 1 minus my r, which is negative 1/2, and I raise that to the 14th power, correct? Over what? Over what? 1 minus r, which is negative 1/2. Again, if it's easier, guys, for you to use decimals, because these are terminating decimals, that's fine. Then you can turn it back into a fraction. But in this case, I want fractions. Everybody see that? Does anybody have any questions about how we're plugging anything in? So you guys are getting like 0.833, positive or negative? 0.833. Now, if I'm not going to give you a problem like this, it's going to turn out gross. I just made this up this morning. But if you had to change this to a fraction, and your calculator doesn't have that button like George's does. Anybody remember? Anybody know how to do this?
Put over like 10,000.
You can put over 10,000. If I just truncated this, if I just said, okay, this is like 0.83, right? What could I put it over? 100. It'd be like 83 over 100. I'm not going to give you one like that. But my main issue is that you guys understand how to plug these numbers in. You will have a calculator. Again, I'm not going to give you one that turns out really, really gross like this. Fractions are okay, but not something that's really hard for you guys to manipulate, to work with. All right, we okay? All right, here's infinite. Infinite's easier. Infinite is much easier. What are the two things you need here for an infinite?
Ratio.
You need your ratio. Your R is your ratio. and your first term. A sub 1 is first term. All right, we don't need to know the number of terms. Why do we not need to know the number of terms? Because it's infinite. It's going to keep going on and on and on and on. There's two ways that you know that something is infinite, to use this formula and not the other one. Either A, it's written in sigma notation like this, and you have your infinity sign on top. Or if they give you a sequence of numbers, say they give you like 2, 4, 8, and then it goes like this. What do those three dots mean?
Etc.
Etc. On and on this kind of ellipsis. So it just goes on forever. So here's some examples. I know that this is an infinite. Why do I know it's an infinite? Because there's the infinity sign, correct? So there's only two things I need to know. I need to know the first term, and I need to know my R. What is my ratio for this one? 0.6. Or 6 over 10, good. But if I start as a decimal, what can I have as my answer? A decimal, so we're okay. How do I find the first term? I'm going to plug in 0. Why am I plugging in 0? Because that's what they're telling me to plug in. If it said 1, I'd plug in what number? 1. If n equaled 12, I'd plug in what? 12. Whatever number starts with. And again, it doesn't matter if it's an n or an I or a k or something like that. It's just a variable. So guys, if I plug in 0, we can do this in our head. If I plug in 0 right here, what's 0.6 to the 0 power? 1. So my first term here is 4 times 1, which is 4. So what's my formula? If it's infinite, what's my formula? It's A1 over what? 1 minus R. So it'd be A1, which is 4, over 1 minus 0.6, correct? Yes? So do that in your calculator. Again, we started with a decimal, so you can have a decimal answer. What is 4 divided by 1 minus 0.6? What's 4 divided by 1 minus 0.6? It's 10. Hit 4 divided by, and then you have to have 1 minus 0.6 in parentheses. But your answer here is 10. So now if I look at B, how do I know that B is an infinite? How do I know that B is infinite? The dot, dot, dot. That means, oh, okay, all I need to know are two things. I just need to know the first term, and I need to know the ratio. So looking at this, guys, what is A1? What's the first term you see? 3, okay? I can't figure out the ratio just by looking at it. Well, you can, but how would I figure out what the ratio is? How do we do that with geometric? Okay, you figure out what's being multiplied. Take one of the terms and divide it by what? The term before it. So it doesn't matter, anyone that you see. So I'm just going to take the second term, which is 0.3, and divide it by the first term, which is 3. So what is 0.3 divided by 3? Yep. So my ratio is just 0.1. So again, this is a very easy formula. You take a sub 1, so you take your first term, over 1 minus your r. So what, and guys, this needs to be in parentheses in your calculator. So I have 3 divided by, what's 1 minus 0.1? What do you guys got? I get 3.33333, right? And again, decimals are okay. Why is a decimal answer okay in this situation? Because we start off with a decimal. All right, this is one that I just made up myself here. How do I know that this is infinite? Because I see the infinity sign. Okay, so I'm like, oh, awesome. I just need two things. I need the first term, and I need my ratio. Looking at this, what is my ratio? 1/3, good. And then how do I figure out what the first term is? I plug in 1. Why am I plugging in 1 this time? I did 0 the last time. Why am I plugging in 1? Because whatever is down here is your first term. Guys, if I plug in 1, what happens? What's 1 minus 1? 0. 1/3 to the 0 power is So my first term is just 6. So in this case, you would have 6 over 1 minus 1/3. So I have 6 divided by 1 minus 1/3. And what do I get? I get 9. Good. Good, good, good. So what is important? What is important? What is important? You guys have to remember the formula. The hardest thing about geometric is actually plugging it in your calculator. In order to find the first term, you just plug in whatever the bottom number is. It's easy. In order to find the ratio, it's whatever is with the exponent. That's easy. And then to find the number of terms in a finite, you just take the top minus the bottom and add 1. All right, you guys with me? Okay.